What's going on, guys? Let's do this problem right here. The question is asking, find the both x and y centroids of the composite shape below. So first of all, what you have to do is, if you have a simple shape, it's easy to find the centroid. But if you have complex shape, what we have to do is we have to break it into simple parts. So in this case, we can break this one as two rectangles. So we are going to have a rectangle on top and rectangle on the bottom. The total distance is going to be 4 plus 3 plus 8 is going to be 7 plus 8. It's going to, therefore it's going to be 15 meter right here. And this height is given 6 meter, and that's all we need to know. Now from this one I can find the centroid. So before I do that, I have to know the equation to find the centroid. So the equation is to find the x bar. X bar, this is x component of the centroids. X bar is going to be sigma a x bar over sigma a. So this is the equation to find the x component of the centroid. To find the y component of the centroid, we have to use this formula sigma a y bar over sigma a. So these are the two things we have to remember. So in this case, so therefore we have to find a sigma a x bar and sigma a bar, sigma a and sigma a y bar. So to find this one, I have to create a table. So let's see. So this is my table right here. So the first column is going to be my parts. So let's divide it into two parts. So since we have divided already, so this is going to be part 1, and let's say this is part 2. Now we have to find the area for both parts. This is going to be meter square. They have said that all dimensions are in meters, so this is going to be, area is going to be meter square. And then we have to find the x bar. X bar is simply going to be the meter. And then we have to find the ax bar. Ax bar is going to be area times meter, therefore the unit is going to be meter cube. Then we have to find the y bar, the area, unit is going to be meter, and then we have to find the ay bar, which is going to be area times distance, so it's going to be meter cube. So these are the all things we have to find. So first of all, let's find it for the part 1. So the part 1 is a rectangle, so the area is going to be the length times the width. So we have the length 15 times 5 is going to be 75. So 15 5, this is going to be 75. Then x bar, so basically for the rectangle, the centroid is going to be exactly in the middle. Also for this rectangle, same thing, the centroid is going to be exactly in the middle. So what is x bar mean is, x bar mean this distance from the bottom to the centroid. So in this case the distance from here is going to be exactly half of this distance, so therefore it's going to be 7.5. so 7.5, and then if I multiply 75 times 7.5, I will get 562.5. So that's basically x bar. X bar means simply multiplication of this area and the x bar, so that's going to give us 562.5. Then I have to find the y bar, but in this case we have to be careful. So before we started to solving the centroid problem, we had to fix a point where we measure the centroid. So I measure everything from this point. Let's say this is the point. So x bar is not going to give us any problem because we are always going to start from this point, right? So and it doesn't matter if you start from here or it's going to give you the same thing. But for y bar, we have to be very careful because the point is going to be in the bottom. So in this case, what I have to do is I have to calculate this 6 and the half of this distance. So it's going to be, it's the total distance is 5. So if I divide it into 2, it's going to be 2.5 right here. So the half of this distance is 2.5. Therefore, if I measure this total distance, it's going to be 8.5. So y bar is equal to 8.5, and if I multiply this 8.5 by 75, it's going to give us 637.5. So that's all we need to know in the part 1. Now let's move to the part 2. So the part 2 area is going to be distance length times the width. So length is given 6 and width is 3, so 6 times 3 is going to be 18. And x bar is going to be same thing. so I had to measure this one from, as I mentioned, this is my point of measurement. So from this one to centroid, what's the distance? So this is 4 and this is 1.5, therefore the total distance is going to be 5.5. And if I multiply ax bar, mean multiplication of these two, so 18 times 5.5 will give me 99. Then y bar is going to be from the bottom to top, so it's going to be 6. The total distance is 6, therefore the half of this is going to be 3. And if I multiply this 3 by 18, I will get 54. Now we have calculated all the values. Now the information we need is, we need to find x bar and y bar. That's the main thing. So in this case, the equation is, to find that we have to need sigma ax. So we have to know this one, sigma ax right here, and we have to know sigma a. So this is going to be total sum of area. So it's going to be sigma a right here, and then we have to know sigma ay. So it's going to be total sum of this column right here. So these are the three columns we have to calculate. So if I add them all together, let's see what I get. So if I add these columns together, I will get 93. And if I add these all columns together, I will get 661.5. And then if I add these columns together, I will get 691.5. Now we have found all the values right here. Now see, we can simply substitute in the equation and find the x bar and the y bar. So if I substitute for x bar is going to be sigma x bar. So sigma x bar we calculated here already. It's 661.5, and the units is going to be meter cube, since this is multiplication of area and the distance. So the unit is meter cube, and it's divided by the total area. So total area is 93, and this is meter square. So if I divide both of them together, I will get 7.11, because and the meter cube and the meter square cancels each other and left with meter. So 7.11 meter is my answer for x bar. And if I want to calculate y bar, I have to simply substitute sigma ay, and that's going to be 691.5 over 93, and this is going to be meter cube, and here it's meter square. So if I divide both of them, I will get meter, and that's going to be 7.44 meter. So this is x component of the centroid, and this is the y component of the centroid. Therefore we know the centroid is going to be exactly 7.11 meter from the x, so it's going to be somewhere here, 7.1. so let's say this is the point, and from the y bar, so from the bottom it's going to be 7.4, so this is somewhere here. So we know the centroid is going to be exactly in this component right here. This is the centroid point. So this is how we find the centroid for the complex objects. So I hope you guys understood this concept, and see you next time.